Have you ever tried to do your own research and look up a real scientific article and then gotten super confused when you get to all the numbers and symbols? Hi, I'm Dr. Sarah Margolin, and I have a PhD in cognitive and sensory processes, and I've been running my own human subjects research lab and teaching classes in research methods for almost 2 decades. Welcome to my series, In Plain Science, where I pull back the curtain on all things science. In this episode, we're going to go over what those numbers actually mean and how you can decipher them for yourself. So in a previous episode, we talked about experimentation and how in an experiment, we may choose to compare maybe an experimental condition with a placebo condition and a no treatment control condition. And we aren't going to look at those conditions and the group means or the group averages with just our eyeballs on a graph and draw a conclusion from that. Instead, we're going to do some statistical analyses and compare those group averages to see if any differences that are happening just by chance because of variation from person to person or group to group, or if they're happening because there's something actually there making them actually different. So you might see some numbers like this with an F and some numbers, or a T and some numbers, and then a P and some kind of number. The F and the T are going to indicate what kind of statistical test they did. Was it an ANOVA, which might give us an F? Was it a t-test, which would give us a T? In either instance, we're still looking for differences between our conditions. And what's going to tell us whether those conditions are statistically different from one another is that P part. So if we zoom in on that P, we want to see that it is less than 0.05. If it is less than 0.05, and in many cases it could be less than 0.01 or less than 0.001, we're going to see that it is very, very, very likely that there are differences between our conditions. And so we would draw a conclusion that says our experimental group is different from our control group, for example, with that P less than 0.05. And that 0.05 number means the likelihood that us drawing that conclusion is incorrect. So because we want to be pretty sure that we're drawing a conclusion that our experimental condition is different from our control condition, and for example, maybe our treatment for an illness is working, then we want the likelihood that there is no difference or the difference that we saw is just a fluke to be as small as possible, which is why we're looking for something less than 0.05. 0.05 is 5%, less than 5% likelihood that we're wrong, which also means it's more than 95% chance that we are correct. So then when we see a p-value of less than 0.05, then we can go back and look at those group averages and kind of see where they place. Is the experimental group having better success than the control group, or are they having less success than the control group? And is the placebo group in there somehow? And so we're going to use that p-value as an indicator to now go look at those means. The mean difference, the averages that are different between the two groups, don't have to be large for us to see significant difference or to see a significant p-value, one that's less than 0.05. They just need to be not due to chance. They have to be real and not just a fluke or based on some variation. And now this explanation works for p-values that correspond to an F or a T, which would be comparisons for experimental manipulations, but also might be for comparisons on things that already exist. But we may also see p-values in correlational research, and I'll do a video on correlational research in the future here. But we're going to see those p-values kind of pop up in all kinds of places. But just know that if that p is less than 0.05, we are not drawing conclusions based on chance. We're drawing conclusions based on what's actually happening. And hopefully this gives you a tool the next time you want to look at a real scientific journal article. Thank you for watching, and follow along for another episode of In Plain Science.